Here we are in section 7-1 with exercises 13 through 29. The first section, write the following as rational exponents. Now remember, rational means fractional exponents. And look at these. Anytime things are written in radical notation, they just look ugly. And so this is really just double checking that you know how to do this, that this means fourth root means that it's a fractional exponent. So this is going to be x to the third power fourth root. And that's really all there is to it on that. This one is m to the fifth power seventh root. Next one, this is p to the first power third root. So 1/3 power is the same as a cube root. Number 16, x to the fourth power fifth root. And just put that as a denominator. Number 17, got two of them in here. This is x second power fifth root and y third power fifth root. And that's really all it is. This little section is double checking that you can convert between a radical notation and rational exponents so that you can, we own fractions. We know how to add, subtract, multiply, and divide them, which is the rules of exponents. So if we can turn radicals into rational exponents, we win the game. And so this one, remember square root actually has a little 2 there. That's the opposite of squaring something. So this is b to the 7/2 power and c to the 5/2 power. Good. All right, this next section, write the following as radicals. Notice we're going to go exactly backwards of what we just did. So this is m squared cube root. So it looks like that. This one is going to be q to the fifth power and an 8th root. So the 8th root of q to the fifth. Then we have the 5th root of t cubed. Yep, indeed. Next one, this is the square root of a to the 7th power. Good. X to the 1/2. So x to the 1. And square root of that, and also the square root of y to the fifth. Yeah, it looks kind of weird where you got fractions up here in the exponents, but yeah, they're both half, so they're both square root of x to the 1, y to the fifth. Good. And then the last one, number 24. X to the 7/4, that's the fourth root of x to the 7th. Excellent. Okay, and in this final section, find the following. All right, so we've got the square root of 11 times the square root of 11. You could punch that in a calculator, and some fascinating stuff happens. This is actually a section about whether or not you understand the concepts of root and timesing itself. So the square root of 11 turns out to be 3.3166. And if we take that number, let's do that answer, and we times it by itself, something amazing happens. We get just 11. This equals 11. And notice what's happening here. We're taking the square root of 11 times the square root of 11. That is the square root of 121, which is perfectly 11. Yeah, square root and timesing by itself, squaring, undo each other. Okay, so the square root of 57 times the square root of 57 is just the actual number 57. Whatever that is, I think it's like 7.6 something. I don't know. Let's punch it out and see what it is. Square root of 57 is, 7.5, blah, 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 blah. If we times it by itself, we better get 57 back. Yeah, because that's what the square root of 57 is. It's the number that when you times it by itself, you'll get 57. So here we have another one, 29 to the 1/2 times 29 to the 1/2. That's the same thing as square root of 29 times square root of 29. Better give us 29. Now notice it also follows the rules of exponents. This is 29. When you multiply like bases, this is 1/2 plus 1/2. Well, that's 1, 29 to the first power. So the rules of exponents, the square root principle, they all combine together. They're all connected. That you can use the rules of exponents, just the concept of what a square root is, and it all works together. So here we have 17, the cube root of 17 times the cube root of 17 times the cube root of 17. Yep, you guessed it. It is going to come out to be exactly 17. Let's go ahead and do that on here. This is 17 to the 1/3 power. So what this is the number that when we take, let's go ahead and take that number times itself, and when you just take two of them and times them together, they won't equal anything really cool, but when you take three of them times them together, you get 17. That's exactly what it is. You took 17 to the 1/3 times 17 to the 1/3 times 17 to the 1/3, which is going to be 17 to the rules of exponents here, 1/3 plus 1/3 plus 1/3, and you'll see it undid it. When you cubed this thing, or you could have done it like this way, 17 to the 1/3 power times itself 3 times is cubed. Notice whatever this does, it gives you exactly 17. You came out of the irrational world of square roots and cube roots and radicals when you have cubing undoes cube rooting exactly. All right, and the final one. Let's do the 5th root of 2 times 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 the 5th root of 2. Let's go ahead and just check what the 5th root of 2 is. 2 to the 1/5 power. It's going to be, I don't know, 1.14 blah, 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 blah. When you take and times this by itself, you're doing the 5th root of 2 times 2 times 2 times 2 times 2 to the 5th power. And these two undo each other exactly. This is 2. And you can think of that as 1/5 plus 1/5 plus 1/5 plus 1/5. Or 2 to the 1/5 power to the 5th power, timesing by itself 5 times. And let's watch it happen on the calculator as well. If we take that answer and times it by itself 5 times, so caret to the 5th power, it better come out to be exactly 2. That's what a 5th root and a 5th power will do for each other. Excellent.